Hi everyone, I am JULKA. Today's topic is properties of determinant. In part 1, we'll talk about how to expand a determinant using properties. Example 1. Expand a determinant using properties, where first column elements A, second column elements B, third column elements A plus B plus C and C plus A. First we take common from each row and each column. In the first column A is common and second column B is common. So we take A and B common from the first and second column. Then first column and second column element become 1, 1, 1. And if the two columns are identical, C1 equals to C2, so value determinant is equals to 0. Next example. Expand the determinant using properties where first column elements A, second column elements A, B, C and third column elements B plus C, C plus A and A plus B. First we take common from each row and each column. In the first column A is common, so we take A common and we'll get in the first column 1, 1, 1 and the second and third column as it is. Now if we add second and third column, we'll get A plus B plus C. So we'll say C3 replaced by C3 plus C2. And first and second column remains same and third column is A plus B plus C, B plus C plus A and C plus A plus B. Now we'll take common A plus B plus C from the third column and in third column we'll get 1, 1, 1 because C1 equal to C3, so the value determinant is equals to 0. Next example. Expand the determinant using properties with the first column elements 1, 3, 5, second column elements 3, 2, 7 and third column elements 6, 11 and 22. If we see the two rows, if we say C3 equals to C3 minus C2, then the first column and the second column remain same and the third column is 3, 9 and 15. And now if we take 3 common from the third column, we will get 1, 3, 5 in the third column and the first two columns remain same. Because C1 equals to C3, so the answer of the determinant equals to 0. Or if we use C3 equal to C3 minus thrice of C1 minus C2, then the third column element becomes 0 and the value determinant is equals to 0. Or if we say C3 is replaced by C3 minus thrice of C1. So first two columns remain same and third column is 3, 2, 7 because C2 equals to C3, so the value determinant is equals to 0. Next example. Expand the determinants using properties where first row element A minus B, B minus C, C minus A, second row element B minus C, C minus A, A minus B, third row element C minus A minus B and B minus C. If we add all these three columns, if we say C1 is replaced by C1 plus C2 plus C3, then in the first column we'll get A minus B, B minus C plus C minus A, or B minus C plus C minus A plus A minus B, and the third element C minus A plus A minus B plus B minus C. Remaining two columns remain same. And in the first column we'll get 0, 0, 0. And the second and the third column remain same. Because all element of a column is 0, so the answer of determinant is equals to 0. Or we can use row operations in which we can say that R1 replaced by R1 plus R2 plus R3. Now in the first row, first element is A minus B plus B minus C plus C minus A. Second element B minus C plus C minus A plus A minus B. Third element is C minus A plus A minus B plus B minus C. And the two rows remains same. In the first row we will get after calculation 0, 0, 0 and the two rows, the remaining two rows are same. Because all element of a row is 0, so value determinant is equals to 0. Next example, expand using properties where first row of the determinants is x plus a, b and c, second row a, x plus b, c, third row a, b and x plus c. If we add all three columns and say c1 is replaced by c1 plus c2 plus c3, so in the first column we'll get x plus a plus b plus c in all three places and the second and the third column remain same. Now we'll take common x plus a plus b plus c in from the first column and we'll get 1, 1, 1 in the first column and the remaining two columns remain same. Whenever we have triple 1, we make 100 using R2 equals to R2 minus R1 and R3 equals to R3 minus R1. X plus a plus b is common. Now there is no change in the first row, but the second row and third row after using operation will get 0x0 and 00x. Whenever we have 3 zeros like this, so answer of the determinants is multiple of diagonal elements. So we'll get 1 into x square. So answer is x square into x plus a plus b plus c. Next example. Expand using properties. A, B, C, A square, B square, C square, A cube, B cube, C cube. First we take common from each row or each column. So in the first column we take A commons, from second we take B, and from third column we take C, and we have 1A, A square, 1B, B square, 1C, C square. Whenever we have triple one, we make 100. We are using of column operation C2 equal to C2 minus C1 and C3 equal to C3 minus C1. First column remains same, and after using column operations we will get first column as it is, second column 0, B minus A, B square minus A square, third column 0, C minus A, C square minus A square. Take B minus A common from the second column and C minus A from the third column, and we will get first column 1A, A square, second column 0, 1, B plus A, and third column 0, 1, C plus A. Whenever we have double one, always make 10 using C3 equal to C3 minus C2. So the first column remains same, second column remains same, in the third column we will get 0, 0 and C minus B. So whenever we have triple zero like this, the answer always the multiple of diagonal elements. So we'll get multiple of 1 into C minus B. So answer is C minus B. Now take minus common from B minus A and minus common from C minus B, and we'll get answer ABC, A minus B, B minus C and C minus A. Last example. Expand using properties. Determinants with the first two elements A minus B minus C, 2A, 2A. Second row elements 2B, B minus C minus A, 2B. And the third row elements 2C, 2C, C minus A minus B. First we add all three rows and we'll say R1 replaced by R1 plus R2 plus R3. So in the first row we'll get A plus B plus C, A plus B plus C, A plus B plus C, and the remaining two rows remain same. Now we will take common A plus B plus C from the first row, and we'll get 1, 1, 1 in the first row, and the other two rows remain same. Whenever we have triple one, we always make it 100, and we'll say C2 equals to C2 minus C1 and C3 equals to C3 minus C1. So the first column remains same. In the second column we'll get 0, minus A, minus B, minus C and 0. And the third column we'll get 0, 0, minus A, minus B, minus C. Since these three elements are 0, so the answer of the determinant is the multiple of diagonal elements, and we'll get 1 into minus A into minus B into minus C multiplied by minus A minus B minus C, and we'll get minus A minus B minus C whole square, and the ultimate answer is A plus B plus C whole cube.